Okay, so we're trying to get set. I'm sending the link now, and we'll trust that all who are online will be able to hook up and have a splendid time. A lot of things we'll do today will be more on the test transmission level. So we trust that in the days to come, we'll be able to get things done. Right. Just stay tuned, relax. All right, so let's see how this goes. Let's see how this goes. I trust everyone is going to hear me very well. But meanwhile, let's see how we can send the link. Let's see how we can send the link. So we can. Try to see how I can get the link ready. Ah. Okay, we're about to hit the road and we trust that everything will work according to plan. Right, so we're just trying to have one or two things. Hit the road. So if you've joined, just be patient, started. right away. Okay, so welcome to the mathematics multiverse. It's Mamu with Jarvis, and Mamu and I explore the multiverse. This is what is called the Midnight Sun Project. The Midnight Sun Project. The Midnight Sun Project. The tag is drawn from the famous movie Wakanda. If you follow that project very well, there's actually the concept of a midnight angel being teased. So that was inspiration behind the name. So some of us will be wondering, why are this class this late? That's the whole concept art. Maybe in the days to come, we will think of reviewing, but it's actually supposed to be ninth class experience. That's the objective. Another important aspect of this project is that it's supposed to stimulate you to do night reading. So we want to encourage students to do night reading. It's purely a community project. It's purely a community project. By way of saying thank you to all who are lovers of mathematics, and those who are trying to come up to speed with mathematics. Another important reason why we're going into this midnight sun project is to deal with a societal issue called malpractice. It's so bad. You go online, you see malpractice materials, math so oh come on, that's so disgraceful. So we are trying to use this project to help particularly those who are in SSCE and GSSE, that will be grade 12 and grade 9, to prepare for their work properly, NECO and then tested properly. And they were trusting that if we work from now to the time of your exam, we would have gained enough ground and given you all the required tools to pass the exam. Now, another important reason why we're embarking on this project also is to help students to build the culture of studying. Students, I know students don't study as much as they used to study again. So we want to see how we can study and using a technique of breaking the whole thing we're going to do in little nuggets, taking the concept by little. So today we're going into the NECO SSCE 2023 examination. But there's something I was supposed to talk about, which I first would help us as students. So I was going to talk about, and I'm trusting that it will help us as students. Please, you may not be in these classes, but you have this love for math. I always believe that there's no knowledge in modern times that's really above you. No knowledge is above you. You can pick it down, you may not fully grasp the concept, but just take it as it is. And with time, you begin to make improvement. So, without much ado, let's go into the work for tonight. We're going to be using some playful and some very funny ways to solve this question. But remember, this is the NECO BEC, NECO SSCE exam. This exam is for 2 hours, 30 minutes, which translates to 150 minutes for 100 marks. So what that technically means is that you're spending about 1 minute and 1 minute, and you're spending about 100, you're spending about 15 minutes to earn 1 mark. You're spending what? 15 minutes to earn 1 mark. So if the question is 8 marks, this you can't spend more than 12 minutes, 4 minutes. I'll come again. You have 150 minutes to attack and conquer 10 questions. This exam is divided into part A and part B. 5 questions for part A, all having 8 marks, and 5 questions from section B, all having 12 marks each, so totally 60. So you expect them to turn in 100 marks in 150 minutes. One of the greatest problems students make in an exam setup like this is this. They tend to want to spend so much time on questions. Oh, I give my students a very simple principle. If it takes you more than 30 seconds to 1 minute to process what the question wants you to do, my brother, my sister, run for your life. Run. Take off. Because any question that takes a lot of your time to solve, as in try to process what to do, will likely affect your confidence. Well, because of the course, we're going to be looking at some of these things. But today, let's start. I'll just start. I'm not going to be taking a particular approach to start. We'll just start and let's see how it goes. We're looking at said NECO, SSCE 2020. Pardon me, I love to play with the markers. So you may see green now. You have red at some point in time, or black. Just keep things straight. All right. So we're looking at paper. That will be paper 2, and paper 2 essentially is your theory. So we're going to run with compulsory questions. That be compulsory questions where you can have an option to choose part A. And in part A, you have 5 questions. 5 questions. When you pick a question, identify the topic first before you engage. So you want to write that one down. In any exam, when you pick a question, identify the topic first before you engage. Every time you come into a mathematics exam, understand this. There are 3 major areas you're playing with. You're playing with arithmetic, algebra, and geometry. Arithmetic, algebra, and geometry. So you must identify what branch the question is going to, or in some cases, how are these branches interwoven. So in question number 1, I've done a very good job before now. I've sent a link where you can actually pick the questions from. So, but if you're watching and you weren't able to get this link before, then at the end of this video, I'm going to post the link, or when we're a little bit busy, I'll post the link for you so you can go back and pick the questions from there, and you're going to have a wonderful experience when you watch this. All right, so question 1 says, question 1 is testing your knowledge of algebra. It says, P varies directly as the square of Q. P varies directly as the square of Q, and inversely as the cube of Z. Sorry, this question is actually testing your knowledge of variation. Under algebra, you're looking at the topic called what? Variation. So how do you go about this? Next important thing, pick the details and get to work. So I know that what says P varies, that is when you write varies directly as what? Q squared, and also varies as what? Inversely. Now inversely will be 1 over ZQ. So when it's direct, numerator to numerator. When it's inverse, it's numerator to denominator. So the next thing, what type of variation is identified here? The type of variation identified here is what is called your joint. Your joint variation. Joint variation is what is identified here. So to go ahead to say P varies as Q squared over ZQ. Now, you now want to make a mathematical statement from this. So this will be P. You change this sign to equal to K. Just that this one topic you don't need to put so much in your head to remember. When you see this proportional sign, mathematically it's what equal to K. When you have this K as a constant, that will be Q squared all over ZQ. The next thing we do is to apply our technique of change your solid to formula. And we make K solid of the formula, but we need to look for K. So K will be equal to P times ZQ divided by what? Q squared. And what does that give us? If you check the question, we're told that P is 5, Q is 3, and Z is what? 1. So what do we do? P is 5, P is 3 rather, 5, sorry about that. 5 times Q of times ZQ, which is what? 1 Q over what? Q, which is 3. That will be 3 squared. Right, so if that is done correctly, that will give you 5 over 9 as your K. The next thing you do is to substitute this value in this expression. So P becomes, wherever I see K, I'm going to put what? 5 over 9. 5 is the numerator, 9 is the denominator. What? Q squared over, so I can equal to sign all because those are numerator over what? Z, 9Z. So what's the next thing I will do? The question says number 1, find the relationship between P, Q, and Z. That's what we have done here. That's the relationship they want you to get. That we have done there. So the next question says, find Z when what? P is equal to 3 and Q is equal to 5. So what do? You will then, what this one is that make Z the solid of the formula. Now, you can pick from here. Now, there's a fun way I do this. Now, watch this. My interest is Z. Now, watch this. If this is dividing this, if it causes quality to multiply this, so I will have what? 9B ZQ equal to 5Q squared. But remember that what my objective is to find Z. So ZQ will be equal to this 9P multiplying ZQ will divide this part. So 5Q squared all over 9P. You know what, to check out my channel, I've done a very extensive job of change of sort of formula. To go to playlist of either grade 9, grade 10, 11 or thereabout. Get very detailed work on change the solid of formula. Now, let me tell you this. You hear this? If it takes you more than 3 minutes to solve any change of subject or formula, please give me a call. It's not possible. There's no change of solid of formula that will take you that long. Because the technique is always very easy. All right, so with that, this it's a cube. When it crosses equality, it becomes what? Cube root. We use the concept of antonyms. Anytime a cube crosses equality, it becomes a cube root. And anytime a square crosses equality, it becomes a square root. If it were square root, it becomes what? Square. If it were cube root, it becomes what? Cube. All right, so with that settled, it becomes a cube root of 5Q squared over 9P. All right, so with that, we need to take care of this part of the board. Right, so I just take care of this part of the board so I have some space to do what I want to do. No worries, record it so you can always go back to see what I've done. Now, Z will be equal to what? What is P? P is 3. What is Q? Q is 5. So it will be the square root cube root of 5 times 5 squared all over what? 9 times what? 3. And there are 2 ways you can go from here. Here you can use your calculator. At this point, you can use your calculator. Nobody's interested in what you do from here. Just punch your calculator and then you get your final answer. So if you do that, this will be the cube root of 125 over 27, which will be what? 5 over 3. So the answer becomes from Z equal to 5 over 3. So by solving that question, you have earned 8 marks. Usually the discussion will be 4 marks, 4 marks, or 5 marks, 3 marks. That's usually the arrangement of the marks for this question. All right, I'm trusting that you understood what has been done. I'll just give us a minute or 2 to process that, then we'll go to the next question. All right, so let's go to the next one. Let's go to the next one. All right, we go to question number 2, and in question number 2, we have another interesting question. It says, okay, 2A and 2B. In 2A, it says the sum of the interior angles. The sum of the interior angles of a regular polygon. The sum of the interior angles of a regular polygon. Now, what branch of math is tested here? This is geometry. What aspect of geometry is called plane geometry? So you need to, or formal geometry rather. So you need to understand what area is being tested. Now, I said the sum of the interior angles of a regular polygon. Now, what do we know about a polygon? A polygon is a plane closed figure with straight sides. That is 3 or more. That is 3 sides, 3 or more sides. So, in solving this question, if we are told it is regular, it means all the sides are equal. The concept of regular means that all the angles and the sides are what? That's something you must keep in mind when solving. Now, we are told that the sum of the interior angles of a regular polygon is 1,440. How many sides has this polygon? Very simple. Now, there is an understanding that says that the sum of angles of the polygon is given by the formula n minus 1, rather 180 minus n minus 180 to n minus 1 equal to whatever it is. So in this case, it will be 1,440. That's the setup of this question. So 180 minus 180 to n 180 into n minus 1 is equal to 1,440. Right, so it means that n minus 1 is equal to 1,440 divided by 180. So n minus 1 will be equal to, so if you want your calculator, I think this should be where you may need to use your calculator. I rarely use calculators, but just to ensure that we are spot on without 8, without 8, such it will be equal to 8 plus 1. Let's confirm whether what we have gotten is correct. Let's confirm whether what you have gotten is correct. So if the sum of the interior angles is 1,440, there are 9 sides, so it will be 9 minus 1, which will be 8 times. There is another way we can go about that. We can, and now we know it is 9 sides. We can divide this 9 by this. We can also go from the approach of exterior angles. But okay, let's keep it very simple. At least we've solved it. So the number of sides we're looking at will be what? 9 sides. All right, so find the size of each interior angle. Find the side of each interior angle. Now, there's a concept that says that the interior angle of a regular polygon is equal to 360 divided by n. N in this setup is the number of sides. So this will be what? 360 divided by 9. That will be 40 degrees. That will be 40 degrees. I see that these are questions you can solve in less than 2 minutes. If you know what you're doing. What's important for you to be able to tell what area of math is being tested? What's the area of math being tested? Oh my goodness, God. It becomes very easy to solve the problem. All right, so the answer will be 40 degrees. Right, so that's for question number 2A. Now, if we look at question 2B, Question 2B is essentially arithmetic. Says find the principal that will earn 29,880 naira in 15 years at 3% per annum simple interest. I'll come again. Find the principal that will earn 29,808 naira in 15 years at 3% per annum simple interest. I had solved this question before, and this is where I want you to be very, very careful. And like I would say, if I'm wrong, you can correct me. There's no hard feelings about it. If I'm wrong, you can correct me. You must be careful when you're answering NECO questions. Take pains to read the question very well. If not, if you just go ahead and answer it, you may make a mistake. It says, find the principal that will earn. The key word there is earn. Now, please, when they say that will earn, it's different from when they say it will amount. Very careful with these two words. I use the word earn, I use the word amount. Now, when they say amount, it's different from earn. If they say that will earn, it is interest. That's interest they're talking about. If they say the amount, that will amount, they're talking about the amount. So very, very careful when you solve these questions. I fell into it when I was going through the practice. I had to consult one of my mentors, by the man who taught me mathematics. Back when I was in secondary school, I had to take up with that. What's his opinion on this? And with that, I had a perspective to what ought to be done. All right, so with that said, it will mean that the principal times the rate times the time over 100 is equal to the interest. Now, because you are looking for the principal, you make the principal the subject of the formula. So that said, P will simply be what? 100I, but this divided is to multiply this divided by R root. So at this point, you can punch your calculator. So what I would advise you to do, just say 100 times 29,880 divided by 3 times time. Punch your calculator and your answer should pop out. So that will be 100 times 29,880 divided by 5. Because 3 times 15 will give me what? 45. And if I've done that right, that will give me 66,400. Now, please be careful to ensure that you put your grade. I'm trusting that what I've done is right. So if I've done this right, this is what I'm expected to get. So to be 100 times, let's take that again, 100 times 29,880. Divided by 5. So if you've done that, that will be 66,400. That's a scale of question number 2. So you discover that these questions are actually cheap and really they don't need to take too much of your time when solving it. So let's give you a little while and then go to more questions. Okay, so so you discover that with the right technique, we are able to solve pretty fast. The right technique, we are able to solve pretty fast. And that will explain the reason why. So you discover that if there will be an exam setup for me, question 1 and 2, I will clear it in 5 to 10 minutes. I'm done with question 1 and 2. Because the key here is for you to know the concept. Like the question 2 we just saw is essentially arithmetic. One aspect of arithmetic is called commercial arithmetic. So you need to know the aspect. Once you know the aspect that is being tested, you will surely be able to solve the questions very fast. Now we go to question number 3. Now, question number 3 essentially will test your knowledge of geometry. So let's see the areas of geometry being tested in this question. I'm going to try to draw the diagram. Okay, it says here that the length of the chord AB, so AB is the chord. In the diagram below is 12 cm with the center O. Now, it's a standard practice in geometry and in maths that anytime you see a circle drawn with a letter O used, it's the center. You don't need to rack your brain about that. It's always the center. So it's a standard mathematical principle there. Now, the next thing you want to take note of here is angle ACB is told to be what, 30 degrees. Now it says find the value of theta. Find this value. Now, what concept is being tested here? It's called circle geometry, and it's taught in SS2. Like in my school, actually, Cambridge Education Center, we need to tweak it to our scheme, and we start this topic in SS1. So by the end of SS1, you can answer this question. So what is being tested is what is called the concept from circle geometry. Now, what rule is tested there? That the angle at the center is equal to 2 times the angle at the circumference. So it will mean that if I have an understanding of circle geometry, it will mean that angle AC times angle ACB is equal to angle AOB. What is the reason? Now, this is where students must be careful. This is where your marks are. Angle at center equal to 2 times angle at second. If you don't write this idea, you don't earn any mark, because this is the argument that tells us that what you know what you're doing. So with that said, it will mean that angle OB theta will be equal to 2 times 30. So I'll be able to have 60 degrees. Now, something else you must remember here. If you draw a circle and you draw a circle and you have a line connecting the center to any point of the circumference, that line is the radius. So by implication, this one will be equal to this. Because OA is a radius, OB will be a radius. So I'll say OB is equal to OA. And it is given. Or I can simply say what? Radii. The radii. It's radii. OA is equal to OB. Now, if that is true, and I know that this angle is 60 degrees, what will these angles be? If I use 60 from one, because one of some of the angles of a triangle is what? 180. If I use 60 from 180, it will mean that what I'm left to share, what the two angles to share will be what? 120. Because 180 minus 60 will be 120. If I divide that equally, I'm going to get 60. Which means that by implication, this triangle I have here is a lateral triangle. Now, the trouble you may have is how to present this work, but you must know so that by the time there's a mistake coming, you'll be able to tell, no, this answer I'm getting is quite wrong. So with that, I'll simply say, this is 60 degrees. I'll simply say, I could call here A, I could call here small letter B, I could call here small letter B. Just to stretch my time. I could say A plus B plus theta equal to 180 degrees. Angles of triangle. But A is equal to B. These angles of isosceles triangle. What? AOB. AOB. So with that said, I will simply say that A plus theta, which is 60, is equal to 180. A will be equal to 120. I don't need to overly tell my examiner certain things. It's obvious and it's clear. And A will be equal to 60 degrees. A is equal to B is equal to 60 degrees. So I've gotten that. Now, they say to find the radius of the circle. Now, because A is equal to B is equal to theta, it follows that OA is equal to what? And it's equal to 60. It follows that OA is equal to OB and is equal to AB. Because this triangle is what? Equilateral. So it means that what? OA radius OA, which is equal to OB, is equal to AB, is equal to what? 12C. Settled. I'm wondering why this question like this is set. Well, that settles that. Thinking. You need to think. You need to think. What I do after any exam, I give it to my students to solve. As they solve, they give me feedback. And I draw from their experience and from what they can see. But the student who was solving that drew my attention to this, I was like, wow, okay, that's interesting. So that's a very good thinking. So you may not use this method. Doesn't mean you are not correct. You may even use a longer method. Doesn't matter. What's most important at the end of the day is let your method be logical and correct. Right. So that's settled. We're not with the radius, so we will now proceed to find the area of the shaded portion. We proceed to find what is called the area of the shaded portion. The first thing you need to do here is to identify what kind of shade this one is. You can't find the area of the shaded portion if you don't know the shape that one is. The shape in question is what is called a segment. What's a segment? A segment is a plane figure bounded by a chord and an arc. So anytime we hear the concept of segment, we're looking at a plane figure bounded by a chord and an arc. So the next obvious question we need to ask ourselves is, what type of segment is this? Essentially, there are two types of segments when it comes to circles as it pertains to majoration. And I think I left out a very important concept here. There are two things, two areas of geometry brought together in this question. There is the matter of majoration, that's talking about plane shapes. There is a matter of circle geometry. And if you stretch it also, there is a little touch of trigonometry. You get it? So that's what modern examiners are going to do. They twist it just to check whether you understand your concept very well. So beyond just solving lots of questions in class, you must make sure you understand the concepts. So with that said, This is a minor segment. It's called what? A minor segment. And for a minor segment, we remove the triangle from the sector. So the area of a sector, the area of a segment, practically, diagrammatically, is removing or adding the triangle to a sector. So if it's a minor segment, we remove the triangle from the sector. So how does that work? So we look at area of minor segments. AB will be equal to area of sector AOB minus area of triangle AOB. Right, so how do you do that? What area of the sector? The area of the sector is theta over 360 times pi r squared minus what's the area of the triangle, especially when it's found in a sector or in a circle. Now, this is where Cambridge becomes very important. If your school is into Cambridge, you discover that this question is about the cheapest question you know. Because this idea is repeated constantly. Now, Cambridge says, because I'm from Cambridge, but that's why I learned the idea. If I have a triangle such that the angle known is an included angle, maybe it's not an included angle is, I have this angle here, and I have this triangle. So this angle is included to this and this, so it's in between them. And I know if I know this side and I know this side, and I know this angle, that angle is called included. Can you say that if I know the included angle and I know the sides, that I can find the area by saying what? Half what? The product of the side sine angle. So because this side is equal to this side, I will simply say that it is what? Half r squared sine theta. So what you need to do at this point is to fit your values. What is theta? 60 over 60 times what is pi? 2 over 7 times what is r? 12 squared minus half times 12 squared sine theta. All right, so at this point you can punch your calculator, or you can write me. I always like to simplify my work before punching the calculator. I like to simplify my work before punching the calculator. So this is what I would likely do. It's what I'm going to likely do here. I'll simply say, let's give you some space to see what I'm doing. I'm saying 12 squared. I'm saying 12 squared. So I'll factor 12 squared. And then I'll deal with this one. 60 over 360 times 2 over 7 minus half sine. Let's put the angle here. Sine what? 60. And I know that sine 60 is actually root 3 over 2. I got that right. Sine 60 is what? Root 3 over 2. So that will give me 12 squared into, I can punch my calculator and get that one. This will be 1 over 6. Right. That'll be 3, that'll be 11. Right with that. So this will be 11 over 21 minus 3 over 4. So we can punch our calculators and then we'll be able to tell what 11 divided by 21 minus bracket open 11 divided by 21 minus bracket open. Let's do the brackets. This one is 0.25 root 3 bracket close, right? All right. So let me do that again. Now be bracket 11 divided by 21, brackets close, brackets open, 5. So that's why I don't like using them. Sometimes when they want to really miss, that will be 0.25. 3 now. 3 years. Right, so that will be I'm just stretching this, but it really wouldn't matter. It really wouldn't matter whether you do that. So that will be 12 squared times 0.0907. 7 what? 7 8. Sorry, 7 8. Something I will advise you when you're using your calculator, be very careful how much approximations you're making. Always try as much as possible not to go beyond 4 places of decimal or 3 significant figures. Cambridge say 3 significant figures. So advise to keep within that range. Your answer will not be screwed out. So with that, I multiply that with so that will be 144 times 0.0906. 0908. And that will give me 13.07 or 08 centimeters. All right. I don't know, really. I don't know what I've done, whether I've solved it correctly. And I've had course where some persons have chatted me privately. Oh, why solving this? You made this mistake. For me, I'm happy because if you can spot an error, just like watching the Marvel Cinematic Universe, and you're like, wow, this effect and whatever. You can spot my errors. For me, this learning has taken place. The whole idea is not to show how well I can solve the problem. Your idea is to create an environment for you to learn and spot the errors. So, what should you be looking out for here? Because not just to solve, our objective is not to solve. You must not forget to put your units. The marking scheme says remove 1 mark for non-availability of units. So if you don't put your unit, you have lost 1 mark there. So these are little things. So when you start, some funny things happen to your students, you should understand why. Can't lose concentration. Can't do that. All right, so that's it to that question 3. And it says finally, it says what type of triangle is triangle AOB? I have treated that already. Triangle AOB is what? An equilateral triangle. Why? Because we have all the angles equal to what? 60 degrees. Standard observation of EA for an equilateral triangle. All sides and angles must be equal. That one here. So you see that we are through with that and we can go to something else. So I'll give you a minute or two to calm your nerves and then we'll get into serial work. Okay, so we're done with that. So let's go to another question. So let's go to another one. I'm trusting that you're gaining something. You're gaining something. I had a simple code I taught my students, and it's this. Never see a question and say you cannot answer it. Never see a question and tell yourself, I can't answer it. The moment you tell yourself, I can't answer the question, you know what happens to your brain shuts down. When you see a question, whether it is simple, whether it is difficult, tell yourself, I can do it. I have students that I take and they'll be like, every question is so simple to you. Oh, it's a trick. Once I tell my brain I can do it, my brain begins to look for a way to ensure that what I have confessed happens. All right, so we're done with that. Let's go to the next question. Let's go to the next question. Go to question number 4. And in question number 4, A, be very careful. Now, the last question we just saw said we should calculate the area of the shaded region correct to 3 significant figures. You know, I got 13.0 something. That answer will not fetch me a mark in the exam. So your final answer ought to be what? 13.1 cm squared. Please confirm that. That was an oversight function. And that's why you can't be too overly confident in the exam. You must pay attention to all these little errors. So please take note of that. Take note of that. It is 13.1. That should be the correct answer. And this is what gives you your mark. Now, question 4A is a question under algebra. Question 4A is a question under algebra. Like I promised, by the end of this class, I'm going to drop on the link one of my Telegram page where you can go. I have a dump site now. It's called the Midnight Project. I have question papers there, so you can encourage your friends and whatever to join the Telegram. You can pick any question paper at all and use that for your revision. I told you that this is a community project, and our goal is to ensure that we kick out malpractice. Even when they place the markings, when they place all the SO online, we should be able to tell ourselves that we will not look that way. These questions are too cheap for us to go online and be embarrassing ourselves. Nice. So we're coming to question number 4. Question number 4 is testing the knowledge of algebra in the matter of indices. So everybody who is in SS1 or who has gone through SS1 should be able to solve this question. But some of us who have gone through JSS2, JSS3, at least you can make an attempt to this question. Let's see what it's talking about. Question number 4. It says solve the equation 7 raised to the power of 2x plus 1 times 1 over 3 raised to the power of minus bracket open 3x plus 2 equal to 9 raised to the power of x plus 3. Now, because we're in the examination hall, so we're thinking of how we're going to solve this problem. We're in the examination hall and we're thinking of how best do we solve this problem. Now, if you go back to my YouTube channel, I've done extensive videos on indices. What I've done there, as a matter of policy, I really teach indices. But by watching my videos, you should be able to understand them. The concept of indices is built on the concept of prime numbers. I'll come again. The concept of indices is built on the concept of prime numbers. So whenever you see a question under indices, look for the prime number present. Okay. If you look at 27, what is the prime number of 27? It is 3. 3 can't, how many now? The concept of indices says what? How many times you multiply a base or a number to obtain a result? So look at this. If I multiply 3 times, I'll get a result. So I'll come here 3 into 3. 3 is the power of 3 into 2x plus 5 times. Look at this. This is 1 over 3 already. Now, 1 over 3 means 3 raised to the power of 1 over, or raised to the power of 3. 1 over 3 means 3 raised to the power of minus 1. Writing from positive index to negative index. That's another law of indices. That's a concept you need to know how to do it. So I can write this to the word 3 raised to the power of minus 1 into minus bracket of 3x plus 2. Now, a sharp student will just know that if this is coming up as negative, take it negative the word positive. You can do that, but I just keep this for purpose of emphasis. This will be 3. If I multiply 3 twice, I'm going to get 9. That will be 2 into x plus 3. What does this give you? And this will be 3 raised to the power of 6x plus 3 times negative and negative give you positive. 3 raised to the power of 3x plus 2 equal to what? We'll put this one 3 raised to the power of 2x plus 6. Now, the concept of indices says that if I multiply 2 bases that are the same, what am I doing to their indices? I'm actually going to be adding them. Multiplication is like adding indices. Division is like subtracting indices. That's the concept you need to have at your make and call here. So with that, we're going to have 3x, 3 raised to the power of 6x plus 3 plus 3x plus 2 equal to 3 raised to the power of 2x plus 6. Just know that what is right. So this will be, at this point, this side is equal to this side, but let's bring it down a little. 6 plus 3 will give me 9x. Now, teachers will talk about collecting of like terms. I've gone past that level. I believe my students should be able to handle randomness. In fact, it's your training to be able to handle randomness. Not every time you make the thing orderly. You should be able to add SS1 and SS3 for this example. Be able to pick and add. So this will add with this. This will add with this. Equal to 3 raised to the power of 2x plus 6. Now, the bases are the same, and because we're dealing with the concept of equation, I can say that 9x plus 5 will be equal to what? 2x plus 6. With this said, 9x minus 2x will be equal to 6 minus 5. And 7x will be equal to 1, meaning that x will be equal to 1 over 7. So if I've done my work correctly, it's something you will need to go back to check. And I just discovered that there's an error. I made an error here. It's ought to be minus 1. So you may want to take note of that. It's minus 1. This is minus 1. So this will be minus 3. This will be minus 3. This will be minus 1. This will be minus 1. But that's something you must be careful about when you're dealing with these questions. Very, very careful when you have problems like this. Thank God I saw it on time. This will be 7. This will be, I thought as much because I was wondering why I would get a fraction. I was wondering why I was going to get a fraction. This will be 7x will be equal to 1. So this error has happened, and it brings me to a very important technique you must do. You must be the teacher of yourself. You must be the one able to detect when you are making a mistake. So while solving, after solving a while, go back, look at the question, go out, there's something I'm missing here, and then you try to deal with that. Solve the question. Right, so let's take care of that. And then we come to question 4b. Question 4b is also algebra. At least at this level of mathematics, we call it algebra. For those students who are doing further maths, we know that further maths is broken down into 3 areas: additional mathematics, 3 areas. We have what is called pure maths, we have what is called statistics and probability, and something we call what's that again? Techniques and vectors. But at your level, we will treat all of this as algebra. The next question talks about differentiation. We say differentiate with respect to x. So now it means y is equal to 2x squared plus 5 raised to the power of 4. Now, I'm going to do something that will shock you now. I'm going to do something that will shock you. The answer to this question is y equal to 4x times 4 into 2x squared plus 5 raised to the power of 3. What is that? How did you get that? Now, so let's rewind a bit. Let's go back a bit now. Because I know I've confused a lot of people. So let's go back a bit. What is differentiation? To differentiate is to scale down. To integrate is to build up. It may not be what would exactly explain the concept, but it's just a way of helping you get into the groove and feel very comfortable with yourself. So when you differentiate, there's a concept that says from differentiation y equal to x power n. That's y by the x. Sorry, this is the y. I'm sorry about that. The y by the x will be equal to nx nx over n minus 1. This is standard differential. This is the one you must what? Remember. So how do we now apply that to problem solving? How do we apply that to problem solving? So in this question, y is equal to x squared plus 5 raised to the power of 4. We will now say let a be equal to 2x squared plus 5. So if I do that, it means that this y, where I have 2x squared plus 5, now put what there a to the power of 4. I see that. Then the next thing I do, I will differentiate each one of them. The a with respect to x will be equal to 4x. Just the 4x. How? The differential of a constant is 0. If you try differentiating a constant, you're going to get what? 0. So now that settles down. Then dy over dA, dy over a equal to what? 4 times a raised to the power of 3, which will be 4a raised to the power of 4 minus 1. I've done a little video on this topic. If you go to my YouTube channel, I think grade 10, 11, grade 11 and 12, you see something called differentiation. Watch it. I've done a very little video on that. So watch it, and I think that will give you a little more idea of what is happening. So with that, the next thing now is to take note of. Now watch this. But what I'm going to do for the y over the x, because I'm going to write as what I base it. dy over the a times a over the x. So the y over the x will be multiplied this with this. For the normal arrangement, if I cancel this, I cancel this. I'll get this one. So it means that if I can cancel this to get this, it seems that multiply the answers from this two. This will now give me 4a cubed times 4x. What is 4x times 4? 16x. What is a cubed? 2x plus 5 all is the power of 3. So 2x plus 5 all is the power of 3. That's something. So you see that what I did by just looking at this one is actually correct. And that's something you must develop. I focus more on presenting the work. There's an aspect when we come to OBG, very fast techniques of answering OPGs essentially will test your knowledge of the concept. You must know the concept. You must know the concept. If you know the concept, you may not. Back in the days, I used to wonder if some student scripts, question paper, I say, looking very blank. I used to feel that maybe there was malpractice or whatever, but when I started developing some techniques, I discovered that a very smart student, who has a strong grasp of concept, can actually go halfway into the exam without even having to write much. Mentally, you can just mentally do this, and it's not malpractice, you can do it. So every time your teacher takes out time to teach you in class, pay attention to the concept. The concept is crucial. Pay attention to the concept. Once you start the concept, every time after that, you will always be able to solve. All right, so that's question number 4. Skeletal break, and then we'll continue. Okay, so while you're doing that, the next one talks about pie chart. I won't be drawing the pie chart. I'll just give you a little idea. I'll simulate what you're supposed to do when drawing a pie chart. I'll trust that will be enough info for you to be able to draw your pie chart. Right, so let's look at the table given to us. In a certain, question number 5. In a certain school, the principal gave the analysis of the qualified subject teachers in the school as follows. Now, it starts with subjects. Essentially, this is an aspect of maths called statistics. In my model, in the mathematics multiverse, the Mamu Jarvis model, statistics in mathematics comes under arithmetic. So statistics probabilities are treated as arithmetic. So other teachers will do otherwise, but that's how I handle it in mathematics. Right, so this is that. You have English, mathematics, you have physics, you have French, you have biology. And the number of teachers, 10 is 4, 6, 4. So we need to get the total. What's the total? 22 plus 18. That should be 40, right? That should be 40, right? All right, so that's 40. The next thing you now need to do is to find the sector. You can call it sector degrees. We can call it, some books will say sector, some books will say angles. Whatever you call it, it what we're interested in is to be sure that what we're doing is right. So I would say 10 over 40 times 360. Why am I using 360? Because a pie chart is a circle. And what enables you to draw a circle is 360 degrees. That's why it's like that. All right, so with that said, this will be what? This should be 90 degrees. Can I actually point your calculator to do this? This is 1 over 4. The quarter of 360 is what? 90. So this is 8 over 40 times 1. That should give me 72. Don't mind me, I always don't like to use a calculator, so it's punch this. This is 4 over 40 times 360. That should be 36 degrees. This is 6 over 40 times 360. That should give me something. This is 12 divided by 40. Because I know that this is 56, it should give me something in the neighborhood of 108. 108. So how am I able to do this? Because I'm also watching the summary aspect. All right. So the next important thing students will do that they ought to do, add up all of this. If it doesn't give you 360, please start again. Add up everything. If it doesn't give you 360, please, your best interest, bank is that now. Start again. So add up 162 plus 90, I think. Or I can take the other pattern, 90 plus 90, 72 plus 2. That should give me 360. The strength of every outstanding mathematician is your ability to recognize pattern. Write this down. The strength of every outstanding mathematician is your ability to recognize pattern. And it's not something you sweat to do. It comes naturally as you begin to release yourself to mathematics. It just comes. I can't explain some things I'm doing. I can't explain them. I try to explain some things, but so it just comes. My decision making comes, just like somebody who's into martial arts. So, with that said, I have confirmed that this is 360 degrees. So, you're not required to draw the pie chart. So let's take you through how you should draw the pie chart. Now, in drawing the pie chart, order is of importance. In drawing your pie chart, order is of great importance, or it is paramount. So, how do you do this? You try your circle first. Don't mind my circle. Take a position. You take your ruler, rule out. Please, you can start from here and move to here. Or you start from here and move to here. Don't do this one. Now jump. We are very organized people. Orderly and very organized people. Don't beat anyhow. So you can start with English. It's 90 degrees. Use your protractor. Measure 90 degrees. Let's say somewhere here. Then you start with English. The next one you call mathematics. Call it mathematics. The next one, physics. Call it physics. These are going orderly. You can go clockwise or anti-clockwise, it doesn't matter. The protractor will help you. After measuring English, you start from there, you measure math. You start from there, you measure physics. After physics, you measure what? French. And the remaining one will be what? Biology. Please Check the remaining one to be sure that it is just what you need. If it is not, again, clean it off and start afresh. Okay, so that's how it is in maths. We are very meticulous people, so we try as much as possible to do these things gradually. So the last question here says, if two teachers are to represent the school in a workshop, if two teachers are to represent the school in a workshop, what is the probability that both will come from either physics or biology? What is the probability that both will come from either physics or biology? That both will come from, the teachers are to represent the school in the workshop. What's the probability that both will come from either physics or biology? Now, this is a question that is treating what is called same color, same person. So how do you handle this? I'll give you. Now, there's also something you need to be careful here. How many English teachers do we have? That both will come from either. Now, it says physics. If I pick the first teacher as physics, I'll get what? Physics is 4. 4 over what? 40. Now, what will the second one be? I'll be left with 39. Now, the question somebody is asking is, why are you doing this? The thinking here is that you're dealing with human beings. If you have taken one physics teacher, you can't replace the teacher. You've taken that one, you're taking that one. So I think that's why I said NECO questions are really very tricky. I think the idea here is that they're dealing with without replacement. So if this is 4 over 40, this will become 3 over 39 plus, or means plus, or 2 words, biology, and that will be 12 over 40 times 11 over 39. Because they said, find the probability that both will come from either physics or biology. So it's without replacement, and you pick the two at once. And because it is all, it means that if both of them are physics or both of them are biology, it will not matter. It means that the outcome, probability outcome will increase. All right, so with that said, this will become what? 12 over 40 times 39. So this is what is this one doing? Plus 132 over 40 times 39. So if I add this, you're going to get 144 divided by 40 times 39. At this point, I can reduce to the lowest end. I can reduce by this, but since we will all be in the examination hall and we all like to use our calculator, sorry, I've been masking. That will be 144 divided by bracket of 144 divided by bracket of 40 times 39, which should give me 6 over 65. So my answer becomes what? 6 over 65. Now let me tell you the truth. Some of these questions, I really don't take out time to solve it. It's really my policy when it comes to preparing students for example. I don't do a lot of the solving. I look at the question mentally. Now, I've actually guided the student through on this question, but what I'm saying now, I didn't pay attention to some of it. And that's why NECO exams are very, very tricky. You really need to pay attention to the questions. If you don't read the questions well, you would assume that what you are thinking in your head is what you want you to do. So that's how we're going to solve this question. And I think we're going to call it a day. My plan was not to go beyond the first 5 questions. So if they're doing a wide setup, this question should have been solved in 1 hour, not more than 1 hour. So 1 hour should be enough time for you to solve this question. All right. Immediate experience will continue on Saturday. But on Saturday, I'm going to, all right, I'll decide what I'm going to do, but I'm thinking I should do either OBJ for grade for senior secondary, and then maybe take out the little time to do for JSS. So we'll likely start with JSS, which is the best, and then after that, we go to the next one. So we may have a situation where that starts with I have to start by 9 o'clock. Or like as usual, I'm communicating to you. Thank you very much for the time. Please share this link to your friends. Encourage them to join the Mambo Jarvis experience. This is a community project. We're not paying for this. Everything we do Tuesdays, Saturdays, basically to encourage the work of mathematics and to say no to online malpractice, explore and coming online. We want to say no to it. And when we're saying no to it is to go to where questions will be solved. In years or in the days to come, we'll be going into physics, we'll be going into chemistry, we'll be into English. I'll get some guys who can come and help us out. We want to say no to malpractice. Have a blessed night and trust you. Have a wonderful time. See you on Saturday. Thank you.